Welcome to the deep dive. This is the place where we take really dense material. In this case, it's the blueprints for managing quality. And we try to distill it all down into something useful, something with high impact knowledge that you can actually apply tomorrow. So let's start with the scenario. I think it's one that probably feels a little too familiar for a lot of people out there. Your development team is flying, the code looks great, but the project is sinking. And you're trying to figure out why.
It's almost always the same story. The testing phase, which is supposed to be the safety net, has become a black hole.
A chaotic black hole, yeah. Defects are found way too late, the environments are unstable, and nobody really knows if they're on schedule or hopelessly behind.
Right. And the critical point here, the thing that everyone misses, is that the problem usually isn't a lack of technical skill. It's not that people don't know how to test. It's a failure in test management.
That's the crucial distinction. I'm so glad you said that. Testing isn't just, a service you order up.
No, it's a strategic business process. And if you don't manage it with clear criteria, with a solid plan, with proactive risk analysis, it stops being a quality safeguard and it starts being the most expensive bottleneck in your entire life cycle.
And that's exactly what we're digging into today. Our focus is Chapter 5 of the ISTQB Foundation Level Syllabus, Managing the Test Activities. We're moving past the mechanics of, say, writing a single test case, and we're zooming out to the strategic command center. We're talking planning, risk, monitoring, control, all of it.
And our mission here is really to help you grasp those core test management principles. That's what the syllabus calls Business Outcome FLBO 15. And alongside that, to help you report on progress effectively and with confidence. That's FLBO 14.
This is the chapter that teaches you how to lead the process, not just execute tasks within it.
It is. And as always, all our material is drawn directly from that ISTQB Certified Tester Foundation level syllabus, specifically version 4.0.1.
We're really focusing on the fundamentals that make testing a managed strategic function, and we've got 5 key areas that all kind of interlock. Okay, what are they?
First, test planning. That sets your mission. Then risk management, which defines your focus. Then you have monitoring and control, which is your feedback loop. And finally, the support structures, configuration management, and of course, defect management.
Excellent. Let's unpack this strategic blueprint for predictable quality, starting with what is, I think, maybe the hardest part, test planning. Because planning is where you take these vague ideas of quality and you have to turn them into actual measurable tasks with a timeline and a budget.
Right. And a lot of people see it as just necessary paperwork. A box to pick.
Exactly.
But a good test plan is so much more than that. It is your single source of truth. It's a communication tool for every single stakeholder. It documents the means, so your resources, your environment, your techniques, and the schedule for hitting your test objectives.
It turns hope into a plan.
It turns hope into a structured path. And just as importantly, the act of writing the plan is this critical mental exercise. It forces you, as the test manager, to confront all those future challenges before they actually happen.
So you're asking the hard questions up front.
You have to.
Yeah.
Where are the risks? What resources will we really need? What's our plan B if the environment isn't ready on time? If you wait until you're in the middle of execution to start asking those questions, you already failed at managing the process.
And it has a governance function too, right? It connects what you're doing on this one project back to the bigger picture, to the organizational standards.
Precisely. The plan has to confirm that your activities are sticking to the organization's test policy, its overall test strategy. And if, for some good reason, you need to deviate from that.
Like, say, you decide to skip a planned performance test because of time.
Exactly. The plan is the official place where you document that deviation, you justify it, and you get the stakeholders to sign off on it. It's all about transparency.
Okay, so for anyone out there who's actually trying to write one of these, the amount of stuff that has to go in can feel, well, overwhelming. Can we maybe break down the typical contents, perhaps following that ISO standard, the 2919.3 that the syllabus points to?
Absolutely. We can group it into about 6 functional areas, makes it much easier to digest.
Perfect.
First up is the context. This sets the boundaries. What's your scope? What's in? What's out? Your specific objectives. And crucially, the test basis.
And the test basis is what exactly?
It's the documentation you're testing against, your requirements, your user stories, your architecture diagrams. If your test basis isn't stable, your planning is just pure guesswork.
Okay, that makes sense. Context first. What's second?
Second, you have to explicitly state all your assumptions and constraints. This is so important. An assumption could be, The test environment will be delivered and stable by June 1st. A constraint might be the entire test effort cannot exceed 200 person-hours.
And writing those down protects you in a way.
It's your justification for change control. If that assumption turns out to be false, if the environment isn't ready, you have a documented reason to go back and say the plan needs to change.
Got it. What's number 3?
Third is stakeholders. This is all about the people. Who has what role? What are their responsibilities? Who reports to whom? And a very practical point. What are the training needs for the team? Do we need to get someone trained up on a specific security tool to execute this plan? That goes here.
I like that. It immediately makes the plan a social document, not just a technical one. You're defining who talks to who.
Yes, which leads straight into the fourth element, the communication structure. The plan needs to define the how and when of communication. Are we doing daily stand-ups, weekly summary emails? It also standardizes the templates for reports so everyone's speaking the same language.
Consistency. Okay, what's next?
Fifth is the risk register. You could argue this is the most important input to the entire plan. It lists all your known project risks, but more importantly for us, all the identified product risks. The plan has to document exactly how the testing activities are going to mitigate those product risks. We'll dive way deeper into that later.
And the last piece.
The last piece is the core operational section, the test approach. This is where you get into the nitty-gritty. What test levels are we doing? Component, system, what test types, functional load testing, what specific techniques like boundary value analysis.
So this is the how we're actually going to do it part.
Exactly. And of course, the big two are in there as well, the budget and the schedule. It's this comprehensive view that takes you from a vague idea to an executable strategy.
A plan that detailed needs clear control points, though, gates. Which brings us to entry and exit criteria. Now, these sound similar, but what's the real difference in their purpose? Why does a manager absolutely need both?
That's a great question, because if you confuse them, you're heading for delays. They serve opposite functions. Entry criteria are forward-looking. They are the preconditions, the things that must be true before you can even start a test activity.
So their purpose is proactive risk management.
100%. If you try to start testing when your entry criteria aren't met, say the environment is flaky or the requirements are still being debated, you're just signing up for wasted time, extra cost, and a whole lot of frustration.
Can you give some common examples?
Sure. Availability of the test item, so the software itself, a stable test environment, a stable test basis, so the requirements are signed off, the tools you need are installed and licensed, and maybe evidence that some basic checks have already passed, like a smoke test from the dev team.
Right, so if your entry criteria for system testing says you need a fully integrated environment, but half the APIs are still just mocks.
The test manager has to push back and say, we are not ready. We cannot start this activity. You're controlling the quality of the input to your process.
Okay, so that's entry criteria. What about exit criteria?
Exit criteria are backward-looking. They define what you need to achieve to say that an activity is done. They help you define the quality of the output.
And what do those look like? Are they just a checklist?
They usually fall into two main categories. First, you have measures of thoroughness. These are your quantitative metrics.
Like coverage.
Exactly. Things like achieve 95% requirements coverage, or no critical defects remain open, or defect density is below 0.5 defects per KLOC.
KLOC being 1,000 lines of code.
Correct. And the second category is more of a checklist, what we call binary criteria. These are simple yes-no process checks. Have all planned tests been executed? Yes or no? Has static testing been performed? Yes or no? Are all known defects logged? Yes or no?
Okay, that all sounds great in a perfect world, but here's the reality check. Management comes in and says the deadline is the deadline, period. And you run out of time before you hit that 95% coverage. What does the syllabus say about that situation?
And that happens all the time. The syllabus is pragmatic about this. It acknowledges that running out of time or budget can, in practice, become an exit criterion.
But there has to be a catch.
Oh, there's a massive catch. You can't just stop testing and walk away. The manager's absolute critical responsibility at that point is to analyze the residual risk. You have to provide clear data on what wasn't tested, what risks are still unmitigated, and the stakeholders, the business owners, have to formally review and accept that risk.
So you turn a testing decision into a business decision.
That's the job. You transfer the accountability for that risk.
And to connect this to, more modern workflows, entry criteria maps almost perfectly to the definition of ready in an agile team.
It does. Is the story ready to be worked on?
And exit criteria is basically the definition of done. Is the story actually finished and shippable?
The correlation is perfect. The principles don't change no matter what life cycle model you're using.
All right, let's tackle the monster under the bed for most managers: estimation. It's so hard to get right. The syllabus says you need to decompose tasks and clarify assumptions. But what specific techniques can we use to make our estimates less like a wild guess and more like an informed projection?
Well, there are two main families of techniques: expert-based, which rely on intuition and experience, and metrics-based, which rely on historical data. Let's focus on the metrics-based ones since they're more structured.
Okay.
The first one is estimation based on ratios. This is where you use historical data from similar past projects in your own organization. For instance, you might look at your last 5 projects and see that the ratio of development effort to testing effort was consistently, say, 3:2.
So for every 3 days of coding, there were 2 days of testing.
Exactly. So if the development team estimates their work on the new project at, let's say, 900 person days, you can apply that ratio and come up with a test estimate of 600 person days.
That sounds great if you have that clean historical data. What's the big pitfall here?
You just named it. The estimate is only as good as the data you feed it. If your organization has sloppy time tracking, or if that similar project wasn't actually that similar,
Right, maybe it was a totally different technology stack.
then your ratio is worthless. The manager's job is to validate that analogy, to really understand how this new project is different from the old one before just blindly applying a number.
A healthy dose of skepticism is required. Okay, what's the other metrics-based technique?
The other one is extrapolation. This is really useful in iterative models, like Scrum. The idea is you start the project, you run a couple of iterations, and you measure the actual test effort you spent. Once you have a stable velocity, you can project that forward.
So if your first 3 sprints each took about 80 hours of testing,
And you have 10 sprints left in the project.
you can extrapolate that you'll need roughly another 800 hours.
Exactly. You're using early data from the current project to predict the rest of it.
But that assumes the work in later sprints is just as complex as the work in the early ones, which might not be true.
That is the assumption, yes. And that's why you can't rely on just one technique. A good manager will use a metrics-based approach like extrapolation to get a baseline, but then they'll refine it with expert-based input.
Like playing poker.
Like planning poker or wideband Delphi. You bring in the team's collective experience to sanity check and adjust the numbers. It's about combining data with wisdom.
We've planned the effort. Now let's talk about how we organize the tests themselves. We have 2 key models here: the test pyramid and the testing quadrants. Let's start with the pyramid. It's become the standard for automation strategy.
It really has. The test pyramid is all about guiding your automation and your effort. Its core message is about balance. You need tests at all levels, but the number of tests should be inversely proportional to how high up the pyramid you go.
So lots of tests at the bottom, very few at the top.
Precisely. The bottom layer, the widest part, is your unit and component tests. They're small, they're fast, they're isolated. You should have thousands of them. Then you move up to the middle layer, your integration or service level tests. They check how components talk to each other. They're a bit slower, a bit more complex. You have fewer of them.
And at the very top,
At the very peak, you have your end-to-end tests, usually through the UI. These are slow, brittle, and depend on the entire system being up and running. You need some, but you want as few as possible.
now here's a thought. I've seen a lot of organizations treat the pyramid as this ideal target they're aiming for, but I think a smart manager should also see it as a reflection of their current reality.
Oh, that's a brilliant way to put it. Explain that a bit more.
Well, if you look at your test suite and it's not a pyramid, it's an ice cream cone, a huge number of slow UI tests and almost no unit tests, that shape tells you something.
It tells you have a lot of testing debt.
Exactly. It reflects a problem. It probably means developers aren't owning quality at the component level, and all the pressure is on the QA team to find bugs at the most expensive, slowest possible stage.
So the pyramid isn't just a guide for the future, it's a diagnostic tool for the present. I love that.
So if the pyramid tells us how to balance our automation, let's move to the testing quadrants. This model seems to tell us what types of tests we need across the whole process.
That's a perfect distinction. There are complementary models. The quadrants, developed by Brian Merrick and Lisa Kristen, help us visualize the full spectrum of testing we need, especially in Agile. It maps test types on 2 axes.
Yeah.
The horizontal axis goes from technology facing on the left to business facing on the right.
So tests for the developers versus tests for the product owner.
In a sense, yes. And the vertical axis goes from supporting the team at the bottom to critiquing the product at the top. So quadrant 1, bottom left, is technology-facing and supporting the team. These are your unit tests, your component tests. They're automated, they run in CI, and they help developers build the thing right.
Okay, then Q2, bottom right, that's business-facing and still supporting the team.
Right. This is where we make sure we're building the right thing. These are your functional tests, your user story tests, things that verify the acceptance criteria. They can be manual or automated. This is where you might use something like Gherkin syntax.
The given, when, then format.
Exactly. Then you move up to quadrant 3, top right. This is business-facing, but now it's about critiquing the product.
So this is more about the user experience.
Yes, this is validation. Exploratory testing, usability testing, user acceptance testing. It's often manual because it relies on real human interaction and feedback.
And that leaves Q4, top left. Technology-facing, critiquing the product.
And this is where your heavy-lifting non-functional tests live. Performance testing, security testing, scalability, load testing, the abilities. These are technical critiques of the system's quality attributes, often needing very specialized tools and skills.
So a complete test strategy has to have activities in all 4 quadrants.
It has to. If you're missing one, you have a blind spot in your quality process.
This strategic planning, especially the quadrants, leads us right into the real driver of all modern testing. Risk. We can't test everything.
We can't. So our plan has to be laser-focused on the areas of greatest danger. Risk-based testing isn't just a good idea anymore. It's a non-negotiable approach for any effective manager.
And what does that mean in practice?
It means that every decision you make, which activities to perform, which techniques to use, how thorough you need to be, all of it has to be driven by a formal risk analysis. Your effort should be a mirror image of your risk profile. High-risk areas get high effort. Low-risk areas get low effort.
Okay, so before we can do that, we have to define what we mean by risk. What are the 2 attributes that determine a risk's overall level?
Every risk is defined by 2 factors. The first is risk likelihood. What's the probability that this bad thing will actually happen?
And then the second?
The second is risk impact, or harm. If it does happen, how bad will the consequences be?
So it's the combination of those 2 things. You could have something that's very likely to happen, but the impact is tiny, so the overall risk is low.
Exactly, like a typo in a help file. The likelihood is pretty high, but the impact is almost zero.
Versus something that is very, very unlikely to happen, but if it did, it would be a catastrophe.
Like a critical data corruption bug in a financial system. The likelihood might be low, but the impact is astronomical. That's the one you focus on. A low likelihood, high impact risk demands a massive mitigation effort.
And in software projects, we split these risks into 2 big buckets, project risks and product risks.
We do, and it's a critical distinction. Project risks are about the management and control of the project itself. They threaten your ability to deliver on time and on budget.
So things like key staff members quitting, or the budget getting cut, or the requirements changing every 5 minutes?
Exactly. Scope creep is a classic project risk. Or your supplier for a key tool fails to deliver on time. These things impact the project.
And product risks.
Product risks are about the quality of the thing you're building, the system itself. If a product risk materializes, it shows up as a defect or a failure in the live system, and it causes direct harm to a user or to the business.
So this is where we're talking about incorrect calculations, security holes, terrible performance.
All of it. Missing functionality, data breaches, system crashes. These are the risks that our testing is primarily designed to find and mitigate.
Since mitigating product risk is basically our core mission, let's walk through the analysis process. How does it work?
It's a very collaborative process, and it has 2 main steps: identification and assessment. Risk identification is basically a big brainstorming session. You get all the right people in a room, developers, product owners, business analysts, testers, and you generate a list of everything that could possibly go wrong with the product. Where could this system fail?
So you end up with this long, maybe scary list of potential failures. How do you prioritize it?
That's step 2, risk assessment. For every single risk you identified, the group works together to determine its likelihood and its impact.
And you use that risk matrix you mentioned earlier.
Often, yes. A simple grid where you can plot likelihood against impact to get a risk level low, medium, high, critical. It's a way to turn a subjective discussion into a more objective, prioritized list.
And that prioritized list has to then directly shape the test strategy.
It has to dictate everything. First, it determines your scope. You're going to focus on the high and critical risk areas. Second, it guides your choice of test levels and types. A high risk around security means you absolutely must plan for security testing in Q4.
And it affects the techniques you use.
Absolutely. A high-risk financial calculation might require formal techniques like boundary value analysis and 100% decision coverage. A low-risk content page might just need a quick exploratory test. And finally, it dictates your prioritization. You test the highest risk items first.
Analysis is one thing, but then you have to actually control the risk. What are the main ways we, as testing professionals, can mitigate these product risks?
Right, so besides just accepting a risk or buying insurance against it, which are business decisions, our job is to actively reduce the risk level through quality assurance. The syllabus gives us a few key controls. One is simply assigning the right people, getting your best security tester to work on the security risks. Another is applying the right level of testing independence.
Meaning for the really critical stuff, you want someone who didn't write the code to test it.
Exactly. You want a fresh set of eyes to reduce confirmation bias. We also have early controls, like performing static analysis and reviews on the requirements and the code itself.
Finding the bugs before you even run the program?
The cheapest time to find them. And then, of course, the dynamic controls. Applying those risk-based techniques, demanding higher coverage for risky areas, and having a really solid regression testing strategy to make sure a fix in one place doesn't break something else.
So we have our plan, we know our risks, now we have to actually execute. And that's where monitoring and control come in. It's the feedback loop.
It is. And it's important to see them as two sides of the same coin. They're related but distinct. Test monitoring is the input side of the loop. It's the ongoing activity of gathering data. It's constantly asking, how are we doing compared to our plan? Are we hitting our coverage targets? Are we on track to meet our exit criteria?
So monitoring is just collecting the facts.
It's measurement. Test control is the output side. It's the action you take based on that data. It's the course correction. The manager provides guidance and corrective actions, we call them control directives, to get the project back on track.
Okay, give me an example. Let's say your monitoring shows that the number of defects being fixed per day has suddenly dropped to almost zero. What's the control directive?
The control directive might be to pause all new feature testing immediately. Then you'd set up a meeting with the development lead to understand the bottleneck. You might reassign testers to focus only on verifying the few fixes that are coming through. You take active steps to address the deviation from the plan.
And that monitoring depends on data, on metrics. The syllabus lists a whole bunch. How do we categorize them to make sense of them all?
We can group them based on what they tell us. First, you have project progress metrics. These are for the project manager. Are we on schedule? Are we on budget? How much effort have we spent? Second, test progress metrics. This is about execution. How many test cases have we run? How many passed? How many failed? How many are blocked?
Then you have metrics about the product itself.
Right. Product quality metrics, things like system availability, response time under load, or mean time between failures. These tell you how good the actual product is.
And the one that probably gets the most attention, defect metrics.
Oh, absolutely. Defect metrics are crucial. Number of defects found, number fixed, defect density. But the most important one, I think, is the defect detection percentage, or DDP.
Let's go deeper on that one. What is DDP and why is it so important? A low score is a huge red flag, right?
It's a massive red flag. DDP measures how effective your testing process is at finding bugs before your customers do. The formula is basically the number of defects your team found divided by the total number of defects, which are the ones you found, plus the ones your users found in production.
So if you found 90 defects and users in the first month found 10 more, your DDP is 90%.
Correct. And a low DDP, say 60%, tells you that 40% of the bugs are slipping through your net. It's a sign that your process is broken somewhere. Maybe your test environment is wrong. Maybe your test techniques aren't rigorous enough. It's a direct measure of your process quality.
So how do we package up all this data from all these metrics? The syllabus talks about two main types of reports.
Right, the test progress report and the test completion report. The progress report is what you send out regularly daily or maybe weekly. It's for the team and the managers to support ongoing control. It needs to be short and to the point. What do we do? What are we doing next? And are there any blockers? It's about enabling immediate action.
And the completion report is more of a look back.
Exactly. The test completion report is written at the end of a major milestone, like a big release. It's a summary of the entire effort. Did we meet our exit criteria? How did our actual schedule compare to our plan? And crucially, it documents the unmitigated risks and unfixed defects that are being carried forward. And it must include a lessons learned section. That feedback is what helps the organization get better for the next project.
So we're communicating status, and it has to be tailored. A developer needs a stack trace. The CFO needs to understand the business risk. What are the key elements to communicating test status effectively?
It's all about translating technical data into business confidence. You have to communicate three things clearly. Test progress, what we've done, quality information, how stable is the product, and most importantly for management, the risks and impediments that need their help to resolve. And the best way to do this is with traceability. Don't just report, we ran 500 tests. Report, we have successfully verified 100% of the critical financial transaction requirements.
You're communicating risk coverage, not just test case counts.
You're communicating what matters to the business.
Okay, none of this works without some solid infrastructure underneath it all. Let's talk about the supporting disciplines, starting with configuration management, or CM.
Configuration management is the bedrock of a repeatable, reliable test process. Its job is to identify, control, and track all the important work products, what we call configuration items, throughout the entire life cycle.
And for testing, that's not just the code, right?
And not at all. It's our test plans, our test cases, our test scripts, our test results, our reports, even the configuration of the test environment itself. All of it needs to be under version control.
So why should a tester care so much about versioning a test plan?
For two huge reasons: traceability and reproducibility. Traceability means you can link a specific test result back to a specific version of a requirement, a specific version of the code, and a specific version of the test case. It's essential for any kind of audit.
And reproducibility.
Reproducibility is about being able to rerun a test under the exact same conditions. Imagine you find a bug. The developer says, okay, I fixed it. You need to be able to confirm that fix.
Which means you need the exact same version of the code on the exact same environment configuration with the exact same test data that you used to find the bug in the first place.
Precisely. Without good CM, you can't guarantee any of that. You might be testing the fix against a different version of the code, and you can't be sure if it's really fixed. CM is the foundation of reliable confirmation testing.
And that's the perfect segue into our final section, defect management itself.
Right. Finding the defect is only the beginning. The whole process of what happens after a defect is discovered is a core management responsibility.
So what's the typical workflow?
It's a structured process. It starts with logging the defect, then analysis, where someone confirms it's a real reproducible bug, then triage, where its priority and severity are set, then the resolution decision, are we fixing it now, later, or never? And finally, closure, where a tester confirms the fix works and closes the report.
So let's get practical. The syllabus expects us to be able to prepare a high-quality defect report. What are the absolute must-have contents to make a developer's life easier?
A good defect report is clear, concise, and complete. It needs a unique ID, a current status, a good title, and the date and author. That's the basic metadata. Then the technical context, the test object and environment. Which version of the software, what OS, what browser, be specific.
And then the most important part.
The most important part, the detailed steps to reproduce. This has to be a foolproof recipe for triggering the bug. List every single click, every piece of data entered. If the developer can't reproduce it, they can't fix it.
Now, I see people confuse severity and priority all the time. Can you quickly break down the difference?
It's a simple but vital distinction. Severity describes the technical impact of the bug on the system. A system crash is high severity. A typo on a button is low severity.
It's about how broken the software is.
Exactly. Priority, on the other hand, is about business urgency. How important is it to fix this bug now?
So you could have a high-severity bug that's low priority.
Absolutely. A bug that crashes the system, but only in a feature that's not being released for 6 months. That's high severity, but low priority.
And a low-severity bug that's high priority.
A typo in the company name on the homepage, right before a major product launch. That's a cosmetic, low-severity issue. But it's a P1, drop everything and fix it now priority.
And finally, a good report needs the expected versus actual results and evidence.
Yes. Clearly state what you thought would happen and what actually happened. And always include evidence, a screenshot, a log file, a video recording. Proof. A good defect report is an investment that pays off in speed and quality.
This has been an incredibly dense chapter, but I think it really succeeds in shifting your perspective. You stop seeing testing as just a series of tasks.
And you start seeing it as a managed, strategic process. A process driven by business risk and governed by clear, measurable criteria.
That's the core idea. A good test manager ensures that the planning provides the blueprint.
The risk management provides the focus.
And the monitoring and control provide that crucial feedback loop to stay on course.
And in the end, your success as a test manager isn't just measured by how many bugs you find. It's measured by the level of residual risk that you can clearly and confidently communicate to the business when they decide to go live.
It really is about being that bridge between the technical world and the business decision makers. Using data to say, here's why we believe this product is ready, and here are the specific known risks we've all agreed to accept.
It's the difference between an informed, confident business decision and just a hopeful guess.
Speaking of informed decisions, we talked about how sometimes time and budget just run out. That can force you to stop testing even if you haven't met all your exit criteria. So imagine this scenario. Your budget is gone. All of your critical high-risk features have passed testing with flying colors, but maybe 50% of your lowest priority, low-impact tests have failed, simply because you ran out of time to get them fixed and retested. You have to release the product now. What kind of non-testing mitigation strategy could you implement immediately to make that release safer for your users?
That's a classic high-stakes scenario. And it calls for an immediate operational control strategy. The answer there would be a contingency plan built around feature toggles or feature flags.
So you release the code, but not the features.
Precisely. You deploy the entire system, but you use those toggles to administratively disable or dark launch the specific features that still contain those unfixed low-priority defects.
So most users never even see them.
They never see them. It protects the customer base, it maintains the stability of the core high-risk parts of the application, and it buys the development team time. They can then ship a small hotfix in the next cycle to fix those minor issues and turn the features on. You're controlling the release of value, and therefore you're controlling the residual risk until it can be completely eliminated.
Managed release is managed risk, a perfect summary of a strategic approach. Thank you so much for guiding us through this today.
My pleasure. It was a great discussion.
That's all for this deep dive. We'll see you next time.